Our new chapter is Chapter 3, Section 1 on parallel lines and transversals. Two lines that do not intersect can be called either parallel or skew. Two different types of lines that do not intersect. We're going to learn what the difference in those two types of lines are. Most of you are familiar with parallel lines. Anything in yellow here is a term that you need to not just know the definition to, but be able to draw and recognize. So parallel lines are lines that do not intersect, which is probably the way you have learned to define them, but we need to be a little bit more specific and make sure that we understand that they are coplanar. Now that's a word we learned earlier this year. You should remember what that means, and hopefully you do remember that it means they lie on the same plane, like a piece of paper or the whiteboard. Know the symbol for parallel, just two straight lines, again, that show that they would never intersect, that you would see this symbol between the names of two different lines. So you'd say line M, and then you would see this symbol line L, and that means that the two lines M and L are parallel to each other. So this is what two drawn parallel lines would look like. If this were our plane, remember the plane goes on forever in all four directions, but obviously we can't draw it that way, so we just draw a portion of the plane, and we have two lines drawn on the plane, like drawing two lines on a piece of paper, or again on the whiteboard or on your computer screen. They never touch, but they are both on the same flat surface, so they are coplanar. We would call those parallel lines. Skew lines are a little different. They do not intersect, just like the parallel lines do not intersect, but this time they are not coplanar. So what would that look like? Well, we still have our plane. One line is drawn on the plane, again, like drawing a line with a piece of paper. And then the other line is going through the plane, as if you had poked your pencil through the paper. You have one line on the paper, the other line going through the paper. So they are not coplanar. They're not both lying on this plane, and they also do not intersect. So they can't be angled towards each other in any way. We call those skew lines. So again, know that term, know what it looks like, know how to draw it, know how to define it. Know the difference between parallel and skew lines. Both do not intersect, but parallel is coplanar, whereas skew is not coplanar or non-coplanar. We can also have parallel planes. Remember, a plane is a flat surface. So if we have this cube, the top would be plane X, the bottom would be plane Y. If they do not intersect each other, then we would call them parallel planes. Again, the same symbol as we had before. Know that symbol. So parallel planes are planes that do not intersect. Okay? So plane X, again, would be parallel to plane Y. We could also call this plane EFG or FEH. Remember, we can name a plane with any 3 points that lie on that plane. A line and a plane are parallel if they do not intersect. So let's say we take this line EF. It would be parallel to the entire plane of Y. They would never intersect. Plane Y would extend on forever in all four directions, but it would never come up to meet line EF. So we would write it like this. Line EF is parallel to plane Y. So again, make sure you understand the notation. That way you don't have to write so many words. Okay, so here's an example. Let's see how well you do. Name all planes that are parallel to plane AEF. So first we have to identify plane AEF. So it's this left side of the cube here. We could have named it FED. Again, any combination of 3 of those points would symbolize the same plane. But it's the left-hand side here, and we want all the planes that are parallel to that. So we don't want to include anything that's touching that plane. So for instance, let me come down here and get red on my pen so we can see a little bit better. Here's our plane. Line AB is touching that plane, so we don't want to include AB. FG also touches, we cross that out. EH touches, DC touches, and EC touches that plane. Okay. So we don't want the top, we don't want the bottom, we don't want the front, and we don't want the back. It's kind of hard to distinguish between those. The only plane that does not touch the left side is this right side plane. Lots of different ways we could name this. GBC, CHG, all different ways we could name it. BHG is just one. But if you understand the namings, you know that it's all the same plane, the right side of your cube. Let's try some more. Name all segments that intersect AF. So first we have to find AF right here. We want everything that touches that. So we want AD, we want FE, FG, AB. All segments that intersect AF. Do you see any more? Remember, it's a segment, so it has to end. So let's see if we got them all. Looks like we did. Name all segments that are skew. This is the hardest one for people to see. So here, whoops. Here's segment AD. We want everything skew to that. Now let's remember what skew is. Skew means that they never touch and they are not on the same plane. Well, FA touches it, so that can't be it. AB touches it. DC touches. And ED touches. So those are out. So let's look at the other ones. EF is on the same plane. They are both on this left side, so that can't be, because skew lines can't be on the same plane. Same thing with BC. It's on this front plane. Same plane as AD, so we can't count that one. Now here's where people kind of get confused. GH is actually on the same plane as AD. I could put a piece of paper going straight across here. I get my pen to work. Down here. I could put a piece of paper in there and those would be on the same plane. So we cannot count GH. So that leaves us with FG, GB, HC, EC, and EH. Let's see if we're right. And we are, 5 of them. So go through and mark each line segment to make sure you've accounted for all of them. You know, you can mark them however you want to. I do an X and a check, but to each his own. Okay, our next topic deals with what we call a transversal. A transversal is a line that intersects 2 or more coplanar lines. So again, we have our 2 coplanar lines here. They're on the same piece of paper, on the same screen, on the same chalkboard, whatever. And they are being crossed by this transversal. Okay, so here's my 2 lines that are coplanar. This line is the transversal. Notice that it creates 8 different angles here. It creates 2 sections of 4. Those 4 kind of go together and make a circle, and these 4 go together and make a circle. So just keep that in mind here in a minute. Okay, if we are dealing with The area between these two line segments, we say that is the interior of the parallel lines. Interior meaning inside. You may have heard of an interior designer. They come inside your house and teach you how to decorate, or they decorate themselves. So interior means inside. We also have two areas that are exterior, like exit. It means outside. So if it's on top of the parallel lines or below the parallel lines, it's like on the outside of those lines. We call that the exterior part of our diagram. Okay, and we name these 8 angle pairs according to their positioning. Okay, so let's see if you understand what a transversal is. Some of a bus station's driveways are shown. Identify the sets of lines to which line V is a transversal. So first we got to find line V. Okay, well here it is right here. So remember, these arrows mean it goes on forever. Forever. All of these lines go on forever. So does U cross it? Yep. Does X cross it? Yep. Does W? Yep. Does Z? Well, if you keep going on forever, yep, out here it does. Does Y? Nope. So what kind of lines are V and Y? They are parallel lines. So everything but Y. Okay? And this is pretty much the same question, only we're looking at line Y this time. Well, if Y is parallel to V, then it's going to cross all of these other lines except for V. So it's a transversal to everything except V. Okay, and hopefully you get the idea. We're not going to go through every single possibility. Okay, so let's get to naming these angle pairs. Alternate interior. The word alternate, again, because this is in yellow, you need to know this term. Again, not just the definition, but how to draw it and how to recognize it when it is drawn. To alternate means to go on opposite sides. Okay, so if we're on the left side and then we hop over to the right side, we alternated sides. I'm going back and forth, back and forth, back and forth. Interior, remember, is this inside area between the two parallel lines. So an alternate interior angles are two non-adjacent, again, should be a familiar word to you. Adjacent means side by side, like these two, number 1 and 2 are adjacent, but 1 and what we were calling 3, that is also adjacent. Okay. Two non-adjacent interior angles on opposite sides of the transversal. So we got to be interior, we got to be inside here, and we got to be on opposite sides of the transversal. So if we're at angle 3, what angle is on the opposite side but still between those two lines? It is the angle that we call angle 6. So 3 and 6 are alternate interior angles. Angle 4 is on the right side of the transversal. If we want an alternate interior angle to that, we got to go to the left side, still between these two lines. So it is an alternate interior angle to angle 5. This pair of angles is called an alternate interior angle pair. Everybody got it? 3 and 6, 4 and 5. Consecutive interior. So we're still inside here, but this time we're on the same side of the transversal. Consecutive just means one right after the other. So if we start here, we just keep going, and the next one that's inside these two would be consecutive interior. So 3 and 5. Okay, so 3 and 5 are consecutive interior angles. They are a consecutive interior angle pair, as is 4 and 6. Same side as the transversal inside these two lines. So we have 2 pair, just as we had 2 pair of alternate interior angles. The next type of angle pair that is created with a transversal is called an alternate exterior. Well, we learned alternate means opposite sides of the transversal. If one's on the left, the other's going to be on the right. But this time they have to both be outside those parallel or those two lines. They're non-adjacent, so I couldn't have angle 1 and 2 because they're adjacent to each other. That doesn't count. Okay, they have to be. Let me erase that so you don't get confused. Maybe. Here we go. Okay, so 1 and 8. Now if we have angle 2, which one is going to be the exterior angle to angle 2? If angle 2 is on the right side, we got to go to the left side, and it has to be on the outside of these two lines. So our only option is angle 7. So 1 and 8 and 2 and 7 are alternate exterior angle pairs. Again, 2 of them. And then the last one is the consecutive exterior angles. Again, consecutive meaning one right after the other. Notice the definition, they are on the same side of the transversal. Here's our transversal. So we're going to be on the same side, but we're not interior here, we're on the exterior. So 1 would be consecutive exterior to 7. And 2 would be the consecutive exterior to what? Angle 8. Again, 2 different pairs. There's 2 pairs of each type of angle that we're learning today. And then the very last one is corresponding angles. Remember, when we first started this, I made note that you get 2 sets of 4 angles here. Corresponding angles are angles that are in the same position of each set. So this angle right here that we've been calling angle 1 is in the upper left-hand corner of this circle. So its corresponding angle is going to be the one that's in the upper left-hand corner of this circle. So these two would be corresponding. Same position, just in a different location. So angles 1 and 5 would be corresponding angles. What's this corresponding angle to angle 2? Well, we're in the upper right-hand quadrant now, so now we got to go upper right-hand quadrant down here, which we've been calling angle 6. So 2 and 6. Now if we go on to 3, hopefully you see the pattern. We would be down here on 7. Angle 4 matches with angle 8. So we actually have 4 different angle pairs that we call corresponding angles this time. Again, know this term, know its definition, know what they look like, where they're located, and how to draw them. Let's do a few examples, and then we'll be finished. So we got angle 7 and angle 3. So this down here is insignificant. We don't need this. So block it out, cover it up, whatever. Well, this one's on the interior, this one's on the exterior. So we don't have interior, exterior for both of them. Therefore, they have to be corresponding. You notice that this angle 3 is in the lower right-hand quadrant, and so is angle 7. So they would be corresponding angles. Let's do another one. 8 and 2. Here's 2. Here's 8. Again, these are insignificant. Okay, well, they're both on the outside of these two lines because here's the inside. So they're going to be exterior angles. Now we just got to decide, are they on the same side of this transversal? Or are they on opposite sides of the transversal? And hopefully you see that they are on opposite sides. Angle 8 is on the left side, angle 2 is on the right side, so we would call them alternate exterior angles. One more, we got angle 4, oops, and angle 11 here. So again, this is insignificant. Forget about it, block it out, it doesn't matter. All we're doing is looking at line A and line C and how that transversal cuts through those two lines. So they're both on the left-hand side, so they're not going to be alternate. They're going to be consecutive, or they're going to be corresponding. So let's check out consecutive. Are they both inside? Nope. Are they both outside? Nope. Instead, they are both in the same quadrant. This is lower left and this is lower left. Therefore, our answer is corresponding. Okay. Seven and 10. We'll just do one more. Okay, so this is insignificant. Same side. And they're both inside. So consecutive interior. It's also called same side interior. It means the same thing. Some books say it one way, some books say another. And that is it. So I hope you understand it. Come to class with questions if you don't.